Hi there, my name is Thomas. Welcome to this session where I will look at beta of stocks and also the fama-french model from 1993, which is a three-factor model built in a linear fashion, just like the CAPM, but with three betas instead of just one, which we know is the case in the CAPM model, originally derived from Sharp in 1964. We will primarily focus on the estimation side and not so much on the theoretical framework side. I encourage you to refer to some other sessions on investmentexcel.com if you like to dig into more theoretical detail on the beta. Generally, beta is a measure of sensitivity, a measure of an individual asset's sensitivity to a predefined market index, and of course originally in the Sharp modeling to the so-called market portfolio. The beta of the CAPM is derived in what is called an equilibrium setup because it's linked to microeconomic behaviors of investors. This is seen in the mean variance setup that Sharp uses. The fama-french model and various other factor models, as they are called, are not equilibrium models. They are merely factor models because the factors used beyond perhaps the market factor are not linked to any microeconomic behavior. Anyway, this video and the Excel workbook are available for download on investmentexcel.com and spotafile.com. But let's see how beta is actually calculated simply in Excel. Of course, we need some data because it's the estimation side, and I have decided just to take 25 days and 25 observations of Microsoft, the Microsoft share, starting from 400 today and ending in 540 almost. And the numbers here are random. So no link to any actual history of the Microsoft stock. Here we have the S&P market starting from 2000 ending in 2250. And here on the right hand side, what we need is the stock return, the simple stock return from T versus T minus 1, T minus 1. So here the first period's return 1.9 on Microsoft, and on S&P somewhat less, 0.40. So these are the core data series that we need to build a one-factor model. And just to be sure, when we do this, this is not the CAPM. Remember, the CAPM is a forward-looking framework. Actually, when we try to build a beta based on historical figures like this, I assume these are historical observed figures, it's what is called an implication of the Jensen one-factor model from 1968. Let's see how the beta is calculated. The beta is simply the slope between these two time series, where Microsoft is the endogenous variable and the S&P has the role of being the exogenous variable. Excel has a nice built-in feature called slope or linus. I use slope, and you see here I choose on the left hand side here F, endogenous variable Microsoft, and exogenous the S&P. So this is simply a linear relationship stating that whenever the S&P increases by 1%, Microsoft increases linearly by 1.96. As this is a one-factor model, there's just one more parameter to be estimated, which is the constant, and we call the constant alpha, because this is what cannot be explained from the market, and of course the intuition is from the original Sharpe modeling, the kappa modeling. So here 0.27, and this is a daily figure. Perhaps some of you will note that this is quite high and indeed unrealistic, but again, the numbers I have chosen are purely arbitrary. But say for instance that we had a more realistic figures that we like to annualize, we would have to annualize this figure, not this figure. This is still the correct figure, it will not change, but this figure will change if we wanted say a historical annualized alpha that Microsoft has delivered over the S&P. Then we would have to multiply this with the number of days in the year. And we can also calculate, to see beta from a different angle, the correlation between the two time series. We use the correl function. We can calculate the covariance and the variance, which is the standard deviation squared. In this way we can calculate beta in a different way by using the covariance divided by the variance, and you see the numbers are the same. So what we have done here, I call it Jensen's kappa model. Perhaps it's a little bit of misuse. Should just call it Jensen's model. Always this little somewhat theoretical thing that the kappa is an unknown future framework, and the Jensen is a known historical framework, historic time series. Over here we see how the linear regression fits in between. Doesn't look like the best model in the world. I haven't tested here how good the model is, because that's not the purpose. The purpose is just to measure, of course, the slope. And once we have defined the model, it will give us the constant as well. So we see here Excel can calculate the model up here as well. Y Microsoft equals 1.9664 times S&P plus the term alpha over here, which corresponds to this. So we can calculate the one factor model here in so many ways. We have one way here, and we have another one here, and we could use with matrix as well, and we can use Excel's built-in function here in data. Go to data analysis and choose regression and calculate it from there, and that will give us some convenient statistical estimates as well that we could use if this was something that we had to apply in practice. So this is the way to calculate the original historical beta. But after Sharpe's modeling of the required return in the kappa by only the market factor, various other models saw the light, and some of them quite famously so. One of them being the fama-french model from 1993, that argued that a required return on a stock cannot only be a function of its sensitivity to the market, because there are other risks, non-diversifiable risks that has to be taken into account. So they argued that the value premium, HML, has to be taken into account, that investors, they require a higher return for buying into lower priced companies, and vice versa. And also here, small investors require a premium for buying into lower market cap versus big large cap companies. And now I just want to calculate beta 1, the market beta, the HML beta, and the S&P beta. And I will just, for the sake of simplicity, take out 5 days. The market here is correct, and then I choose some arbitrary numbers for the daily HML and S&P, and I calculated it. Excel doesn't have a built-in formula like this with various slopes. We could go to, obviously, the data again and the data analysis and calculate it from there. What I have done here is to use some vector and matrix calculation. This is a very famous formula stating that the entire parameter estimation is given by this little beautiful formula. X is the entire matrix here, where the alpha has to be set to 1 in order to capture the alpha parameter, and the xt is the transposed, and y is the MFS T of Microsoft. So once we have set up the linear formulation in a X vector and in an X matrix, we can just go ahead and use the matrix calculation features in Excel, which I have done here, and it looks very, very ugly. I could have shown it more nicely by aligning or assigning a name here, X and Y. So we'll just do that quickly. So I call this X, and I call this Y, and then we try again and just start here. So the beta is equal to the mult transpose of X times X, and then we have to take the inverse of this, and the inverse of this we have to multiply. This is something that needs to be learned slowly, and then we try again the transpose of X, close that, and then we have the last one. So even though I have relabeled the vector and matrix, I must say it's still a little bit ugly. Okay. So this is where it really gets nasty. So we'll just try again, and you can just close the video, but I insist. So again, mult transpose x. Yes. Okay, that was the failure. X. Yes. And M inverse. And once we have the M inverse, we have the M mult times the transpose x. And if this doesn't work, then we will just leave it. And the last one. And the last one. Y. Okay, there we go. So you see, they are the same numbers, slightly different arrays. Let's see. Okay, so that's the way to do it. And with that, I will say goodbye.